In problem 16, they want us to find the domain for each of these individual functions. Okay, so for part A, everyone should realize that this is a quadratic, so the domain of this is just going to be all real numbers. In part B here, you have to realize this is a rational function, so we want to make sure to never divide by 0, so we ask ourselves what value the denominator would give us a 0, so I solve the denominator for 0, and that tells me that 2x is equal to 9, so x would have to be 9 halves. So I would say this: all real numbers x such that x does not equal 9 halves. For part C, it's a square root, so we want to make sure everything under the square root is always greater than 0. So I would set 3x plus 1 is greater than or equal to 0, and I would solve, and I would get x is greater than or equal to negative 1/3. So I would say all real numbers x such that x is greater than or equal to negative 1/3. Part D, another rational function, so I would make sure that the denominator could never be 0, so in this case I would factor it, and I would factor the denominator of x squared plus 4x minus 21 into x and x, and probably 7 and negative 3, 7 and a negative 3 positive, right? So that adds to a positive 4 and multiplies to negative 21, and then solving each of these individual pieces for 0, I would see that x cannot be the number 3 in this case, and x cannot be the number negative 7. So I would say all real numbers x such that x is not equal to 3 or negative 7. And then the last one here, I'll move up just a little bit. This is the square root. So this particular piece is x needs to be greater than or equal to 1. And this particular piece underneath the radical, x needs to be greater than or equal to negative 2. So if I draw a number line, put 0 here, put 1 here, put negative 2 here, this would be the number line associated with this one, and then in a different color, this would be the number line associated with this one. And you can see that both of them are true when x is greater than or equal to 1. So my domain would be all real numbers x such that x is greater than or equal to 1. And that's problem number 16.